We defined a rational function to be a function of the form p of x over d of x, where p and d are both polynomials. We saw that we can simplify rationals if p and d have common factors. Now let's look at some more examples. First, let's simplify 4x over 3x squared plus 6x. Remember, we can only simplify a fraction if p of x and d of x have a common factor. Remember, we can only simplify a fraction if p of x and d of x have a common factor. So to see if p of x and d of x have common factors, we need to write them in factored form. Our constant a times x minus our first root times x minus our second root, and so on down the line. Now the top is already in factored form, 4 times x. To factor the bottom, we can factor out 3x, leaving us with 3x times x plus 2. Now, we can make the simplification that x divided by x is just 1, because we have x as a factor in the top and x as a factor in the bottom, leaving us with 4x over 3x squared plus 6x equals 4 over 3 times x plus 2. It's worth pointing out that x over x equals 1 as long as x is not 0. So this equality is only true for x not equal to 0. At 0, our right-hand side is defined, but the left-hand side is not.